Okay, compound inequality. So still working a little bit with inequalities, moving into the compound ones. So for this one, we're going to fold this top over. There we go. So it ends up looking like that. Again, we'll cut along this line here in the middle. Whether you cut now or later does not actually matter. On the last video, I didn't cut first, but I switch it up and do it first this time. So compound inequalities. There's two different kinds of compound inequalities. As you can see, we have what we call and inequalities, which means it has to fit both constraints, is the word that we use, the both situations. Or we have or. So or, it has to work in either one of them, but doesn't have to work in both. Okay. So taking a look at the and ones. So looking at this top part. Most of the time, they write them in this fashion. So you have two inequality symbols, some stuff on the left of it, some stuff on the right of it, and then stuff in between the two inequality symbols. Sometimes they actually write two separate inequalities and then they just put the word and in between them. It's the same thing. No matter which way that they write it, it's the same exact thing. So it really does not matter too much. So my little note on the top, it says, when solving and inequalities, it's best to separate them into two inequalities and then you solve. So you're going to take the one double inequality, so to speak, you're going to make it into two inequalities. So taking a look at this first one here, one inequality would be negative 16 is less than 3x plus 5. My second inequality would be 3x plus 5 is less than 35. So the stuff in the middle gets used in both of the inequalities. And then you got the first inequality symbol there with a number, and then the second one there with a number. And then you're going to solve them just like we were doing before. So here I would subtract 5, which would make that negative 21. Divide by 3, so I end up with negative 7 is less than x. Other one, I'm going to subtract 5. Divide by 3, and we get x is less than 10. So both of those numbers need to be on my number line. I need to have both the negative 7 and the 10. You don't have to number everything in between them. You don't. As long as you got those two in there, there's some spaces between them. They're not right next to each other. So then we're going to write an open circle on the negative 7, open circle on the 10. And based on our inequality symbols, our shading here is going to be in between them. Because x is greater than negative 7. So greater than negative 7 would be going here to the right of the negative 7. But it is less than 10. So it's going to be going to the left of the 10. So this is how we make our number line for our compound inequalities. Now, the one other thing that we do like to do is there's another form that we like to write our answers in. We didn't talk about it with the other ones because we were practicing. It's called interval notation. Interval notation. So interval notation is just a way, as I said, of being able to write the answers to your inequalities in a quicker format. So with interval notation, whenever you have an open circle, you're going to use the symbol of a parenthesis. And because the shading is in between negative 7 and 10, we would write this as negative 7, comma 10 with parentheses around them. So this is saying in interval notation, open circle on negative 7, and then it's going all the way up to the 10 with an open circle at 10. So it's not including negative and 7 and 10, but it goes from those two numbers. That's what our interval notation is. Again, it's just a way of being able to write it. Let's try our next one. So again, I'm going to set up my two inequalities. So I'm going to go ahead and solve the one on the left first. So I'm going to add 4. And then I'm going to multiply by 2 to get rid of my 1/2. And I get x is greater than or equal to 12. Again, going from the x, the variable. This one I'm going to add my 4. Oops, left off my x. I'm going to multiply by 2. And I get x is less than or equal to 32. So I need to get a 12 and a 32. These are closed circles. Shading in between. Now if you notice, I'm putting these shadings on my number line actually above the number line. It doesn't matter. There's not a specific reason other than I want to make sure you can see where I'm shading. That's the only reason why I'm putting it above the number line. I could be putting it exactly on the number line. I could have put it below the number line. It doesn't matter as long as the shading is close or on to the number line. So in our interval notation for this one, because we have closed circles, we're going to use a bracket. So this time our shading goes from 12 to 32, and the bracket is showing us that those are closed circles, meaning that the 12 and the 32 are going to be included values on that. All right, so our last example here. I accidentally threw my pen. I have a combination of inequality symbols on this one. I have a or equal to, and I have one that is not or equal to. So I'm going to subtract my 3. And I'm going to have to multiply by -4. So when I multiply by -4, remember our sign flips. So x is actually less than or equal to -16. So on my other side, again, I'm going to subtract my 3, multiply by -4. So I get x is greater than -32 on this one. So this time my -32, that's actually going to go on the left side of my number line. My -16 is going to go more on the right side. -16 is considered a larger number than -32. I'm going to have an open circle on my 32, closed circle on my -16. I put it on the number line this time just to show you it really does not matter. And my shading is going to go in between them. So for my interval notation, it's going to be a parenthesis next to the -32 because that one is open circle. And it's going to be a bracket on the -16 because that one is going to be a closed circle. All right. Taking a look at those other ones. So these ones are a little different because these ones are or. Okay. So or inequalities, as you can see, these are already spread apart. You already have 2, 1, 2. You just have that word or in the middle. Or. So these ones are already set for us, okay? So we're going to solve each inequality, and then we're going to do our number line, and then we're going to talk about what's going to happen. So this time we're going to have 2 pieces when we do our number line, but again, I'm getting ahead of myself because I'm excited. So here I'm going to subtract my 6. So that gives me 6 is greater than -5. I'm going to divide by -5. My sign is going to flip, and it's going to say it's -6/5 because I can't really do anything else with that one. So over here again, subtract my 6, and then it's going to give me a 9, and that's going to give me x is less than -9/5. So my number line, I'm still going to do -9/5. -6/5. All right. Both of them are going to be open circle, but the shading is not going to be in between them. This time x is greater than -6/5. So that's going to go to the right from -6/5. And x is less than -9/5. So that's going to go to the left. for that one. So our ORs are going to create shading going in the opposite direction. It's not going to be in between. It's going to be on the other ends. So our interval notation for this one is a little bit trickier. Because this shading keeps going on forever, it's going to keep going on to what we call negative infinity. And we call it negative infinity because it's just infinity on the negative end of the scale. So it helps provide us with a direction instead of just calling it infinity. We know negative infinity would be on the left side. And then that shading ends at negative 9/5. And then we write the word or. And we got our negative 6/5. And the right side is our positive infinity. Now we have to have or because you can't be in both places at once. So or needs to be there. And parentheses always on your infinities because infinity does not have an end. So you can't put a bracket. You can never put a solid circle anywhere there because it just keeps going on forever. So that one is always going to be a parentheses. So always parentheses on your infinities. All right, let's try again. Okay, multiply by 5. That one's done. Multiply by 2. That one's done. So I got 15 and 30. Both are closed circles. X is less than 15, but greater than 30. So again, this shading is going to go towards negative infinity to begin off. And then it's going to end at 15 with a bracket, or 30 to positive infinity. Parentheses always on infinity. Brackets for those closed circles, and then that word or in the middle because you can't be in two places at once. Unless you're standing like over a state line, then you can be in two states at once, but that's like it. All right, last one, multiply by 3. That one's set. Divide by 2. Got that one. So negative 33. 13 seconds, closed circle in 13 seconds, and then open circle. I just remembered there's a little typo on this one. Yep. This is supposed to be a negative 2 because I wanted that sign to flip. That one should be a negative 2 because I wanted that sign to flip. So now X is greater than the negative 13 seconds and less than the negative 33. So that gives us our two shadings. So our interval would be negative infinity to negative 33, or negative 13 halves, positive infinity. All right, so then go ahead and glue that in your book.